Okay, this video is to go through the rehanding of a Trine EN400 strike. This client ordered the strike from us and the hand was not determined at the time of order, and the client needed to send something back to us. There was an electric deadbolt that was, long story short, it had to go back to the manufacturer to be reworked, remanufactured. So this is obviously fail. Aha, that's what it is. Yeah, it's obviously fail secure. So right now, the electric deadbolt had to go back to the manufacturer to get reworked. And he said, hey, would you mind if I ship back the strike for you to rehand? I said, yeah, that's no problem. Wires must face up for unit to operate. Okay, I don't recall the particulars of this job very well. I don't remember what we did on this. And let's take a look and see. Now I believe I've rehanded these in the past, and I recall it being less than the most captivating way to spend my time. But this slider, part 3, has to be flipped over. Yeah, indeed, it is called slider. And I think the spring also has to be reversed, if I recall correctly. Yeah, okay. Right hand assembly and left hand assembly. They're right. They're here. So disassemble the back cover and the solenoid of the left hand configured EN strike using the assembly pin. So we're right here. Disassemble the black cover and the solenoid of the left hand configured EN strike using the assembly pin. Push the latch pivot pin out. Take the latch and spring and the slider guard out of the frame. There's lots of pages here. Lots of steps. Align the slider with the pick guard ribs as shown. Assemble slider guard over the slider. Yeah, you've lost me. Pass the long leg of a spring through the rectangular hole on the frame and let the latch assembly drop to position where all the pivot holes line up. Insert latch pivot pin, making sure that the flared pin head is towards the right as shown. Assemble the solenoid and secure it with the solenoid screw. Okay, so let's do this. Let's just investigate what this thing looks like. We know it's left hand because this is a fail secure. Strike is indeed what it is. It's fail secure, and the keeper's locked. If we turn it upside down, it's no longer locked. So we know it's a left hand because we know it's fail secure. I know that it's fail secure. We are going to need some screwdrivers, so I will grab that. Yeah, this is the type of keeper for a cylindrical or mortise lock, the type of electric strike. This, I'm sure, will work with 1/2 inch or 3/4 inch projection because of the depth of that keeper. They've got the entire rear removed, so let's do that as well. Let's remove these 2 screws and see what happens. You know, the bottom line is this was assembled by hand. So we really can't get ourselves in too much trouble. The issue is you end up sometimes removing screws that you don't need to. Looks like somebody started to take that one apart. The client's installer may have said, pass. We've got 3 different size screws here, actually. Small, medium, and long. This, the longest one, came from here. The smallest one came from here. The middle length came from here. So I'm going to put those back in order that I took them out. It might need a little bit of coaxing to come out. Let me get my coaxing tool. Yeah, it's just down there tightly, that's all. Okay, so that stainless sheet metal cover has come off. And I know what they're referring to. Yeah. And it's also nice to be able to also figure out why it works and why it doesn't work. Yeah. So, you know, what you have here is your coil. And what happens is, yeah, it's pretty simple and straightforward. You know what? Let's demonstrate why this works. This is 12 volt DC. Let's go to the effort and demonstrate why this works. Well, here's what's going to happen. The slider is down in here. And when we energize the coil, a magnetic field is going to be built up inside of that. And it's clearly going to force the slider to move to unlock strike. So when it energizes, the slider will come up. So right now it's locked. When it's energized, the slider will have to come up, allowing that keeper to be in an unsecured condition. It's really amazing electricity in the sense that it's really all about how magnetism is created in an electric field. It's just everything. Transformers, it work exactly that way. The way that you charge your phone is exactly that. A magnetic field is built. You run electricity through a coil that induces, and I've learned and forgotten the terms many times, but that induces another magnetic field. It induces the magnetic field when you plug your charger in. The touchless chargers, the magnetic chargers, whatever. I know Android had them before Apple did. it creates a magnetic field. You put your phone down on there, it creates a magnetic phone in your field, in your phone, allowing you to then charge. That's just how that works. It's just simply brilliant. I should say the people who thought it up. Let me go grab a power supply and let's play with this. I went and fetched a Lochnetics, ouch. I went and fetched a Lochnetics 510. And I have a cable that I can then plug in. So let's move these parts out of the way. I'd like to demonstrate how this actually works. I'd like to see it actually work. So I'm just going to plug in our incoming power. Yeah, TB2. This is where hot and neutral will go. This oh, you can't see that. It's TB2 right here. These terminals. So let me just get that, get our wires connected here, and also connect our ground as well. Polarity is not mandatory for AC voltage, but they want the left terminal to be for hot or black, and the right terminal to be for neutral or white. I don't know what the output terminals are here, but it's surely marked. Boy, it would be handy to have a smaller pair of hands, I guess, once in a while. This strike is 12 volt DC. I don't think I have a plug-in transformer that's 12 volt DC. I shouldn't have pulled it all the way out. Got it started back in there. I'm going to try to snake that wire underneath the head of the terminal screw. Oh, yeah. That's good. Okay. Got the black wired in. Get the white wired in now, or the neutral. No problem. I'm going to wire the ground as well, since we're here. I'll tell you, I would not want to work inside of power supplies all day long, that's for sure. Just, it's not fun. And because I don't work in them all day long, that's why I'm not very proficient in working in them all day long. Alright, we got that threaded into the back plane. Now, bottom line is, oh, I don't have a voltmeter here. Shoot. Both of my multimeters are at home. So if this doesn't work, I won't be able to tell you why. I don't have a voltmeter. If that's the case, I will pause this video and we'll pick it up again on Monday. Pardon me, today's Saturday. I'm going to plug in the power supply. Well, it's plugged in. Yeah, I've got a green light, and a green light I mean, sometimes the lights are red. I mean, I know that means something. Yeah, output power indicator, green light. So I've got a green light, which is right there. Got a green light on my power supply. So I've got output voltage. Now I know that the jumpers are set to 12 volts because I can see that they're set to 12 volts right there. That jumper is set to, or slider, I suppose, is set to 12 volts. And someone just texted me, so okay, not a problem. Yeah. All right, so let us take a look now. On my description of the output terminal block, looks like terminals 5 and 10 are the output. No, 3 and 4. No. Oh, no. I'm looking at the dual control module. Yeah, on the main board, 1 and 2 are standby battery. 3 and 4 are the emergency override. 5 and 10 apparently are the output power. 5 is negative, so that's where the black wire will go. 6, 7, 8, and 9. Yeah. Yeah, that's going to be for jumper is removed only if ER option is used. Okay. Yeah, so let's try to just plug this in. I do not. I've got a white and a white-orange wire on this. I don't know what that is, so let's consult the installation instructions. Not that much is going to happen on here out of the presence of anything to happen. Aha. Okay, so this is 12 volt DC. You got two orange stripe. Are these? Yeah, they're both white orange. Yeah, I don't have my. It would be nice if I had my voltmeter. Because it's not, we can't really tell what's happening. Let's get that put in there. Yeah, okay. Alright, so what we're going to do is look at the instructions to confirm our output terminals. Okay. Yeah, it's 1 and 2 are control switch. Okay, that's the DCM. That's the TDM. I'm looking through the manual of the power supply to make sure of what my output terminals are. C notes, okay. Okay, 12 volts, Figure C, we've got a fail secure lock, single, yeah, 5 and 10. That's for fail safe. Fail secure, yeah, it's going to be, yeah. So the only difference there is going to be that our contacts, our switches would be normally closed, held open. Normally closed, held open is going to give you a locked condition until you power or close the circuit and then unlock the lock temporarily. Yeah, so it's 5 and 10. There's no doubt about that. It's definitely what it's saying. Okay, so we're locked. 5 and 10. Yeah, I'm getting, don't know why I'm getting nothing out of this. What is this? 12 and 24 volts. Yeah, let's look. And unfortunately, I can't tell you if we have output power truly. So we might just pause this till Monday. We may not be getting output power here. Okay, so yeah, we're going to have to confirm where we have output voltage and then go from there. I took both of my multimeters are at home because I'm working on an article regarding pursuing the EHC credential, the Electrical Hardware Consultant credential. And something's not exactly right with this power supply. Actually, what it could be is because we have the EIR, the Emergency Interface Relay, I may not be jumpered, is what could be the problem. That could be the issue. So I'm going to pause this video. And it won't seem like a time delay to you at all. We will pick this up in 2 days' time when I'm able to determine where my output voltage is. But jumper is removed only if the EIR option. Yeah, so we are not hooked up to an EIR, and there is supposed to be a jumper between 5 and 9. If EIR option is used, the output power to the lock will be interrupted upon activation of the EIR. Sure. Well, actually, I suppose that really shouldn't matter. So we're going to pick this up when I can get my multimeter here and determine why we don't have action. And quite frankly, when you're troubleshooting a circuit, yeah, it took a little bit of time for that LED to go out. When you're troubleshooting a circuit, quite frankly, the first thing is, do I have power? And right now I don't know if I have power, so we have to determine where is our power. Let's pick this up come Monday. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, well it is now Monday morning, and I have brought my trusty multimeter, one of my two. So the bottom line is I wasn't getting, as you recall, output voltage at all from our power supply. And the power supply is this Locknetics 510. And the bottom line is we're getting a green indicator telling us that we have output power, but the instructions in the lid literally tell us, it shows us the output terminal, or you know, the terminal block, description of that output terminal block. Jumper is removed only if ER option is used. We're not using the ER option, which is terminals 3 and 4. We don't have an emergency interface relay, we don't have a connection to a fire panel. That's going to open this circuit, dropping off power to anything that this is powering. So we don't have that, which means there was no jumper. Well, now there is. Before I started this, I jumped, according to the instructions, to 5, 5, and 9. So at 5 and 9, I've got a jumper wire on that. My output terminals are 5 and 10. 5 is negative and 10 is positive. You can't see 5 and 10. Doesn't matter. So on my multimeter, I'm going to set it to volt DC, to the range that I expect, which on this is 200. It's 220, 200, or 1,000. So I'm expecting, well, actually, no, I'm expecting to see 12 volts. So I'm going to turn it to 20. I'm expecting to see 12 volts because I have it slid over to 12 volt. So 5 is the negative terminal. So I'm going to put my negative probe on the 5th terminal. And then my positive terminal is 10. Yes. There you go. 13.75 volts. So now I know I've got output voltage coming off my terminal block. 10% plus or minus is typical. Okay. Why is that a little heavy? Well, it's not unusual for a power supply to produce more voltage right off the bat, because you know that you're going to have a loss in terms of resistance. You know, you're going to have ohms resistance is measured in ohms, and you know you're going to have a loss, a resistance loss. So now, where did all this start? I wanted to simply show you how this worked. And what I'm predicting is, with the coil installed, is the locking slider is going to move when you power the coil. What's going to happen is it'll force that to happen. When I power the coil, so right now it's left hand, so it's locked. When I lift the locking slider, I'm now unlocked. And obviously what has to happen is when this is powered, that's going to click. So I'm going to run my power. I'm going to touch my leads to 5 and 10. Yeah, definitely. I don't know if you can hear that, but it's definitely clicking. Actually, let's put it this way. You'll be able to see it move. Yeah, did you see that? I think you can see it. Yeah, focus right here. And that's the action. That's the only thing that's happening there. When our switch, whatever our switch is, passive infrared, keypad, doorbell button, key switch, card reader, whatever, it's going to energize. That magnetic field is going to create... a magnetic field will be created in the coil, and it's going to force this piece of steel to be attracted to the metal coil. And that small movement is all that's required to unlock that. Okay? That's all. So, I've demonstrated that that works. Yeah, well, what I was trying to do was to show you that it was unlocked, and the keeper was unlocked. So, we know how it works. Now what we have to do is go about reversing it, and that's what we're going to do next. And it basically requires pulling the pins out, pulling the slider out, pulling the spring out, pulling the slider guide out, and simply flipping that slider, that locking slider over is really all it is. So that's what we're going to move to now. I will leave this power supply right here for a future job, future demonstration. Okay, now let's physically take this apart and get to work on that. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Oh. Okay, now it is most definitely quite true that I've not done this in a while, but let's see if we can get through it. So, all I've done is I've removed the coil from the unit, and I know based on the installation instructions we have to push the latch pivot pin out with the assembly pin is what we have to do. So let's break an egg. Oh, okay, so it's all one piece. Okay. All right, so we're going to need to remove this. That much I know. Just going to put that down right there. That spring, the slider guard. Let's pull the spring out. Let's pull the slider guard out. And as far as I know, all we need to do is to reverse that. And only go back in one way. Put the guard back in. Put that spring back in there just the way we found it. Yeah, that spring's going to fit inside of here. Then we're going to push the pin all the way through. I highly doubt this is going to work the first time, because I remember the first time I did it, it took me a month of Sundays to get it back together. And this video is to kind of help teach me again as to how I went about and did it. Actually, yeah, I might actually have it back together correctly. Okay, so I can see down in here I'm not able to push the pin back in because I know that my spring is jostled loose. Yeah, and this is what I recall being difficult, getting that to sit there and be nice, behave. Okay, that may have worked. Oh, nope, I had it. The spring jumped on me. I rotated it. Okay, so all I'm doing is pushing that back down in there, and I'm holding the spring in with my finger. And I'm going to make that tip of that spring go right back into that slot where it was after we push the slider back in. Let's see about getting that back in there. Okay. I'm going to hold that down. I'm not going to rotate it. And when I look down in that hole, it appears as if I've got the spring lined up with the back side of the keeper. And the latch pin, I'm going to put in the opposite direction, from the opposite end, which I believe is what the instructions tell us to do. That does not want to go back in there. I can see because my keeper is not seated down properly. And it's probably because the slider is in a bad spot. Yeah, it is. Let's pull that pin out, and let's try all that again. Yeah, so the spring moved on me, that's for sure. And if I recall correctly, I actually used a tool. Yeah, the spring moved. I actually used a tool to get all of this held in together. I think what I did was I slipped something like this down in the opposite end to hold it together until I pushed the latch pin down in. Ah! I had it, I think. Ah. Nope, the spring fell over. There must be a trick I'm missing. Pass the long leg of the spring through the rectangular hole on the frame and let the latch assembly drop to position. Okay. So I think what they're... Oh, it's not going to work like that. Although it was just like that. I wonder if I actually am doing this more difficultly than it needs to be. Yeah, no, I'm not. That needs to be compressed. You son of a gun. Pass the long leg of the spring through the rectangular hole on the frame and let the latch assembly drop to position where all the pivot holes line up. Uh-huh. That is easier said than done. That's where it's starting to creep out. Right there. Oh, sir. It'd be all right if it just stayed in place. Right hand assembly fails secure. Yeah, we've got it incorrect. Yeah, I see what's happening. You know, that slider's got to be completely clear inside of here for this to be able to rotate. That's the bottom line. The amount that's open on the slider guard, this piece of stainless, when that slider moves, it's going to prevent the keeper from rotating. So we can understand how it functions, which is important to being able to put it back together naturally. Pass the long leg of the spring through the rectangular hole on the frame and let the latch assembly drop to position where all the pivot holes line up. Well, doing what they said, I'm going to let that pass. Oh, you know what? I wonder. Could that be? Could it be this, that simple? No. Definitely not that simple. No. That's how it's got to go in, because that's the only way. And I can tell you what the issue is that I can't, my finger's too thick to get the spring seated and get the finger pulled out at the same time. That's the problem. We will be sure, we will be absolutely sure to get the hand from the client the next time. Okay, that's all in place. Now, if I had a tool small enough, actually, no, that won't work. If I had a very small pin, I could slide that assembly pin in there. I could hold it together while I snuck it in, and then drove that pin out. I bet that's how they do it at the factory. I might have something. That would certainly be the answer to this. An assembly pin. That's the problem. Right there. Yeah, you know, and many times when you're working on things, especially locksmithing equipment, you do need 3 hands, it seems. So close. So they, oh, no. Oh, I think, nope. No, I didn't. Spring folds over on me. Bet that's how they do it. And in fact, yeah, they do have an assembly pin mentioned here, and that's the problem. We're trying to do it without an assembly pin. That might have got it. Maybe. Nope. All right, we are gonna need to come up with an assembly pin. That's all there is to it. Oh, they include one. Son of a gun. You know, maybe that's why it took me so long last time. What's the moral of the story? Read the installation instructions. Going to put the spring the way it is. Going to stick an assembly pin through there, which now keeps it. My problem was getting my finger out before the spring popped out. With the assembly pin, it sits super nice. Super nice. Now we'll drive our latch pin in. And that goes in really easy. This is in the up position for a right hand or left hand reverse. Okay, it's locked. If I turn it upside down, it's now unlocked. Okay, so the moral of the story is if you don't have this, you need to make one. Unless your finger can be compressed to about 1/8 of an inch, you're going to need an assembly pin. Okay, so an assembly pin is the key. So then what happens is our coil goes back in. I'm going to say that it can only go in one way. Yeah. Then what I'm going to do... Oh, no, hold on. Hold the phone. It has to be up on the top because it's a right hand. There's only one way for that to go back together. Okay. Well, at least I discovered the issue independently. And I guess the point is of that painful exercise is that we must be extremely mindful. I guess what I was trying to drive home is that taking it apart and learning how it works, understanding how it works, allows us to solve the problem. And okay, we've got that put together. The wires are coming out nicely. We had 3 screws, if you recall. The first one we took out was here, and then second and third, so in reverse order, because if you recall, they were different sizes. Really short one. That does not like going in there. That longer one's for sure going to go here. Yeah, I don't believe that that's supposed to have that short of a screw because it doesn't go back together very well. And in fact, it does look as if someone took this apart before I attempted to do it because the screw is stripped a little bit. And I don't believe that this is broken, but it may be. That screw is just too short for that. So I will replace that before we send it to the client. Yeah, so we've got a screw. It's right, it's not, it's a right hand is the bottom line. From your perspective, left hand reverse or right hand. It's locked. I turn it upside down, it's unlocked, which means that the slider moves real nice. So what is the ultimate test? Obviously to pull out our 510. Plug it in, make sure it works. Getting output voltage, and if it was, I believe it was 5 and 10 that we needed for the terminals. You won't be able to see that slider anymore, but it's locked. Now, I can hear the slider move. It definitely moves. Terminal 5. Stay there. Probably can't hear it move, but I sure can. So that definitely works. So I do have some really tiny screws. This looks like it is a, quite frankly, a screw for an armor front. So I will pull that out and replace that. So what was the moral of the story? When you drive out the latch pin, you need to have the assembly pin, which was in the hardware. And as I'm looking at the installation instructions, I'm saying, yeah, we need a piece of material. We need a bar short enough to slide in here so it'll hold the spring in place. And I know the first time I did this, I think I was able to get lucky and just get my finger out with setting the spring down so it didn't collapse and fall out of the cavity on us. So the key is you need the assembly pin. If you've got the assembly pin, you'll be able to do 100 of these an hour. No doubt about it. Okay, that tells you how to reverse this, even though a quite long-winded scenario, but now you know what to do. That's advantageous. Thank you very much. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.